Welcome back to the solutions manual. In this video, we will solve the problem 2-33 from RC Hibbeler Engineering Statics 14th edition. According to this problem, we have to determine the magnitude of the resultant force and its direction measured clockwise from the positive x-axis. So to solve this problem, first of all, we have to resolve these forces into their components along the x and in the y-axis. So for 400 Newton force, I have a horizontal component and the vertical component. For 800 Newton force, I have a vertical component and the horizontal component. Let's label them. So the vertical component of 400 Newton force is 400 sine 30 and the horizontal component is 400 cos 30. Similarly, for the 800 Newton force, the vertical component is 800 cos 45 degrees and the horizontal component is 800 sine 45 degrees. So far we have resolved the forces along the x and in the y-axis. Now for the resultant force, the x component of the resultant force, which is Frx, is equals to the sum of the forces in x direction. I am considering right hand side as positive. So we have 400 cos 30 plus 800 sine 45 degrees So upon simplification, Frx comes out to be 912.1 Newton. Similarly, we have to do the same for Fry, which is sum of the forces in y direction. I am considering up direction as positive. So we have 400 sine 30 minus 800 cos 45 degrees and why do we have it negative? Because 800 cos 45 degrees is acting in the downward direction and I have assumed upward direction as positive. That's why it's negative. So upon simplification, Fry comes out to be negative 365.7 newtons. Now for the magnitude of the resultant force. We can use the Pythagoras theorem, which is a square root of Frx square plus Fry square So we have square root of 912.1 square plus 365.7 square. So the magnitude of the resultant force comes out to be 982.7 newtons. So this is our first answer. We also have to find the direction of the resultant force. So for direction, if I draw the resultant force on the xy plane, then it would look something like this. This is the positive x-axis, this is the positive y-axis, this is the negative x-axis, and that's the negative y-axis. So we have frx which is positive and fry is negative. So by using the head to tail rule of vector addition, this is the frx which is positive along the positive x-axis, and using the head to tail rule of vector addition, this is fry. And the resultant can be drawn from the tail of the first vector to the head of the last vector. Let's label them as well. So this right here is frx, this is fry, and this is the resultant force Fr. And since we have to measure the direction clockwise from the positive x-axis, so we have to find this angle actually. Let's call this theta. So for theta, we can use the ratio of tan. So tan theta is equals to magnitude of fry over frx. So we have negative 365.7 divided by 912.1 and applying the modulus, we have tan theta is equals to 365.7 over 912.1. So if you take the tan inverse of this value, then theta comes out to be 21.85 degrees. So this is our second answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and turn on the bell icon for the daily updates. And if you have any questions or any doubts in the resolution of forces or in finding the direction, then feel free to ask in the comment section and I will try to answer them as soon as possible. Thank you.